of engineering graphics and solid modeling. We are going to be constructing a question. It just has to do with a projection of planes and solids, and we are going to be relating it according to the horizontal and vertical plane. So if you watch this video, do very well to like, share and subscribe to our channel, as more of these videos is going to be coming out. So thank you. The question is going to be displayed on the screen. You can see it. So it says an hexagonal prism with side of base 25 millimeter and axis 60 millimeter long is lying on one of its rectangular faces on the horizontal plane. So we are asked to draw the projection of that prism which its axis is parallel to both horizontal plane and vertical plane. So now the construction part says that draw the right side view of that hexagon keeping an edge on the XY line. So what they are telling us there is that they told us that hexagonal prism is lying on one of its rectangular faces. We know we have hexagon. Hexagon is a six-sided shape. So, and this is a prism. It extends. If you are using SolidWorks to construct it, you first create a hexagon, then you use extruded boss to extrude it to the back. So you have an hexagonal prism. So what they're telling us now is that if it is lying with one of its rectangular faces, that means it is lying flat. So one of its edges is touching the vertical plane. So if you are looking at it that way, we have the hexagonal prism in this way. You can see that this is the hexagon, and they said it is lying with one of its rectangular faces. This way it is lying. So you can see that it's a rectangle that is lying on the ground. So now if you are constructing the right side, this would be the right side. That is this place. If you are looking at it from the side, you'll be seeing only the pentagon. If you are looking at it from the top, you will see three rectangles. You will see the top one, which is displaying the actual length, the 25 millimeter. Then you also see the other sides, but you will not see the complete length. You only see the small part of it because it's bending actually. So then for the front view, you will see two rectangles, which are B and C here. So in that way, we are going to be constructing now. So to construct the right side, first thing that you do when you construct is to draw your XY line. That was not much of our time. I want us to quickly rush into that. So I call that XY line. XY. I can use pen because so that it can be visible very well. So take this our XY line, and we already know that our right view, or we call it side view, will be the actual shape of the hexagon. So I'm going to be drawing an hexagon. And what's an hexagon? It's a six-sided shape. We just say n minus 2 into bracket 180. So that's 4 into bracket 180. Then that will be equals to 720. So that's 720. If we divide it to six parts, that will be 120 degrees. So let's just do that without wasting our time. So yeah, this is the XY plane. We measure 25 millimeter, which is 2.5 centimeter. So you can just from here to here. That's our 2.5. So we take our protractor. We target this point here. Then we measure 120 to this point. So we have it here. This is 120 degrees. So you draw a faint line. Then you have that. You come and measure another 25 millimeter along that new line. We are just trying to construct our hexagon. So we have 2.5. And you draw a bold line to that place. After that again, you take your protractor, place it along that line and target the center. Then that's how you're going to find 120 again. So when you see 120, we connect it to that point. So that's how you're going to do it for all the lines you're going to be doing. So you measure another 2.5 here again. So the remaining one here is going to be 25. So and that's your pentagon. So you can name all the sides. You can name all the sides. You can say this is A, B, C, D, E, F. Then you already know this is our XY line. So now you have constructed our pentagon, and you can just put your 120 degree so that you can know that that is your 120 degree. So now we are going to be projecting to the right hand side. They said you should take a line that is another x1 y1 line that is perpendicular to this xy line. So that's what we are going to be doing, is going to be taking that perpendicular line, and you know perpendicular is something like this. We are having something like this. So that's perpendicular. So I'll just say this is x1, this is x1, this is y1. So wherever it stops. So I'm projecting all the edges from here to this place, right? So let's be doing that shortly. So this is what we have here. So we can now take the front view from here. You can take the front view from here. So we are going to be having, draw a vertical line. Just make sure your T-square is clipped to the board very well to avoid mistakes. So, and I'll measure 60. You know the axis is 60. So I have to measure 60 here. When I measure 60, it comes to this point here. I measure 60 also. It comes to this point. So I connect both lines together. So now this is the front view. You know I said when we were taking the other time, I told us that the front view will be only this side, because when you are looking at it from here, you only see B and C. So that is this part that we indicated here. So I'll just try building it out now. So this is what we have. So here, you can just label the parts. This is 60. So this is 60 millimeter. And remember for this I can just label this also. You know this is 25 millimeter when we were measuring it. So this 25, this 60. So now if you want to get the top, you can project this downwards. You can project down and get your top. But in the question I don't think they ask us to do that, but for the sake of learning, let us do it. So this is the side view. Let me indicate them. This is the side view. That's the actual hexagon. So here is the front view. And now we want to get our top view. That one is very easy. Since you have your front view, you can get your top view. Just project it downwards. So just like that, you just project from where you stop here, jet downwards and jet downwards too. So after that, you pick any random point because you're not dealing with any measurement. So you just pick. Now I want us to note something. When we are viewing it from the top, you notice that it's only this place. When you are looking at it from the top, let me use this analogy. It's only this place that is going to be of true length. That means that 25 millimeter. Any other sideways that they are seeing from the top is going to be little than this because it's slant already. So I represent that by 5 millimeter, and I represent the original part by its original length, which is 25. So we are going to be having 25 plus 5 plus 5. That's 35 millimeter. So I'll just measure it downwards. I'll measure it downward. 35 millimeter. 35 millimeter. And I connect. So let me take out my 5 millimeter that is at the sideways. So I have this taken away. So here I connect them. I'll have something like this. So I can just broaden it out. For the sake of more clarity, I will use my pen to broaden out the original part that we got, so that we are going to really get the point. Pencil might not be visible very well, so I'm going to use Biro to represent it. So I represented this as 35 millimeter, where this is 5 and this is 5 and this is 25. So that is just the length. So now we have our top view here. So that is just it. So let me just, for sake of more clarity, let me just use my pen to broaden out our drawings so that we can get the full view very well. That's our side view. That's our front view. And that's our top view. Thank you very much. Do well to like, share, subscribe and comment to this video. More are going to be coming very soon. Thank you very much.